Okay, Wildcats. Today we are looking at Tuesday, October 9th, solving 2 and 3 variable systems with matrices. And that's going to be on page 16. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, also on page 16, solve 2 and 3 variable systems with matrices. To solve systems of equation with inverses, and that's just a system of equations, with the inverse, you first write the matrix equation AX equals B, where A is a coefficient matrix, X is a variable matrix, and B is a constant matrix. The matrix equation representing, and let's use this as an example, 1x plus 1y equals 8, 2x plus 1y equals 1 is shown. So matrix A is 1, 1, 2, 1. The variable matrix is xy, and matrix B, the constant matrix, is 8, 1. So you've basically taken the equation and made a matrix equation out of it. So to solve AX equals B, multiply both sides by the inverse A inverse. So you have AX equals B. You multiply both sides by A inverse. So the variable matrix X is equal to A inverse B. And that's really what we're going to focus on. Is once you have this, you use this in your calculator and you solve. So if you would, finish up your notes. All right, now that your notes are updated, let's take a look at the examples, which are also on page 16. All right, solve the system of equations. So the first thing you do is we need to write AX equals B. So A is 2, 3, 4, 3. The variable matrix is XY, which equals the constant matrix 12, 12. All right, so at this point, what we need to do is multiply. We'll take AX equals B, and we need to multiply A inverse by both sides. So that's A inverse A X and A inverse B. Well, A inverse times A, they basically negate each other, become the matrix 1, 1, but in essence, they're gone, and you're left with X equals A inverse B. So to solve, all you have to do is we have XY equals A inverse, which is 2, 3, 4, 3 inverse times matrix B, which is 12, 12. Now at this point, you're going to use your calculator to plug this into your calculator, okay? So to do that, we go to New Document, No, Add Calculator, and we go to Menu. All right, wait a second, we don't got a menu. That's silly. We're going to press the matrix button, which is the button next to 9 right here, okay? See it right there. All right, now you want to pick this button right here, okay? And then the A matrix it has 2 rows, 2 columns. So you're going to put 2 tab 2 enter, and then that's 2, 3, 4, 3. Now your cursor's inside of there. We need to click to the right once, and then we're going to press this up key, the key right below the equal sign. -1. Click to the right times. You're going to press the matrix button next to 9 again. Now in this case, it has 2 rows, 1 column. So 2 tab 1 enter, 12, 12 enter, and you've now solved the problem. So matrix xy equals 0, 4. Okay, so x equals 0, y equals 4. All right, so finish up example 1. All right, so now let's take a look at example 2. So same thing, we start out with ax equals b. So that's matrix A is 2, 3, negative 4, negative 6, xy equals 12, negative 18. All right, and next part is, again, we know we have ax equals b, and we need to multiply both sides by a inverse. So that's a inverse ax equals a inverse b. In essence, this becomes 1, so then you're just left with x equals a inverse b. So then we set up a matrix, so that's xy equals 2, 3, negative 4, negative 6, inverse times b, which is 12, negative 18. Okay, so now we're going to use a calculator. I always go to new document whenever I start a new problem. No, add calculator. Then we press the button next to 9. And then this is a 2 by 2. And then 2, 3, negative 4, negative 6. Click to the right one. Up key, which is below the equal sign, negative 1. Click to the right times the matrix button again. In this case, it's a 2 by 1. And then 12, negative 18. Now, you get singular matrix, meaning there's an error. Okay, when that happens, you can't solve using the calculator, so you're going to have to actually solve it algebraically. Okay, so we now need to come here, and we need to solve it algebraically. So the way I think we should do it is here, we can probably use elimination, because if we multiply the first equation by a positive 2, the x's will cancel. Okay, so let's do that. So when you do that, we're going to multiply the first equation times 2. So 2 times 2 is 4x. 2 times 3 is 6y. 2 times 12 is 24. And that's equation 1 times 2. Now we're just going to use equation 2 minus 4x minus 6y equals negative 18. And that's equation 2. And then we're going to use elimination. So that becomes 0, that becomes 0. So you're left with 0 equal to 24 minus 18 is 6. 6 or 0 will never equal 6, so that's no solution. All right, so now let's take a look at example 3. All right, so first things first, we know we have we're going to need to have ax equals b. So then that's matrix A is 2, negative 1, 3, negative 1.5 times xy equals 12, negative 6. All right, so now we know, again, we have ax equals b, and we need to multiply both sides by a inverse. So a inverse ax equals a inverse b. This, in essence, is blurry. Becomes 1, so you're left with x equals a inverse b. So then we now set up our matrix. So xy equals 2, 3, -1, -1.5 inverse times matrix B, which is 12, -6. So now this is where we use a calculator. All right. Again, press enter to OK. I'm going to go to on, new document, no, add calculator. Press the matrix button again. It's a 2 by 2. So 2, 3, -1, -1.5. Click to the right, -1. Click to the right. Times matrix button again. In this case, it's a 2 by 1, 12, -6. Now you get singular matrix again, meaning you can't solve with the calculator. You're going to have to solve it algebraically. Okay. All right. So I'm looking at eliminating it because both the x and y are on the left side, and it looks like if I multiply the second equation by 2, 2x minus 2x will cancel. Okay, so let's do that. So this is equation 1. This is equation 2. So we're not doing anything to equation 1. So 2x plus 3y equals 12. Equation 1. We're going to multiply 2 by equation 2. So 2 times -1 is -2x. 2 times -1.5 is -3. And then 2 times -6 is -12. And that was equation 2 times 2. All right. Well, 2x minus 2x is 0. 3y minus 3y is 0. So you have with 0. And then 12 minus 12 is 0. 0 will always equal 0. So this is infinite solutions. All right. So let's look at example 4. All right. Example 4, it has 3 equations, 3 variables. And you would think it'd be more difficult, but it's not. It's the same process. Ax equals b. So a is 2, 4, -3, 3, 3, 4. If there's not a number in front of the letter, put a 1. So 1, 1, -2. X, Y, Z equals 17, 17, 6. All right, so AX equals B. We multiply both sides by A inverse. That becomes 1. So X equals A inverse B. So X, Y, Z equals 2, 4, -3, 3, 3, 4, 1, -2. Oh, I'm sorry, inverse, don't forget about inverse, times 17, 17, 6. All right, so this is where you use your calculator. So I'm press OK, then we go to on, new document, no, add calculator, press the matrix button. Now in this case, it is a 3 by 3, so you can press enter. And so then that's 2, 3, 1, 4, 3, 1, -3, 4, -2. Click to the right, inverse, -1. Click to the right, times matrix button again. Now in this case, it has 3 rows and 1 column. And so then that's 17, 17, 6. So we can say that X, Y, Z equals 0, 4, 5. So x equals 0, y equals 4, z equals 5. All right, at this point, start working on your assignment. Now, I've left you with 3 problems, which is enough to have finished before the class is over. So I'll give you some time to finish it, and then I'll check for completion, and then we'll go over the problems together. So with that, start working on your assignment and have a wonderful Wildcat day.